Hey guys, it's Mike Mass. Welcome to another one of my series of RV lithium upgrades. In this film, I introduce you to my latest lithium design, which is my 5112 dual voltage, dual inverter lithium system designed specifically for large RVs like this Canyon Star. There's a total of 4 Lithionics 51 volt battery modules which output 30,720 watt hours used exclusively for 120 volt inversion. With its Victron Quattro 5000 watt inverter, the system could run 2 air conditioners and a cooktop at the same time. My other compartment houses my 12 volt lithium system powered by a Lithionics 12 volt module developing 4,032 watt hours. This system is used solely for 12 volt devices such as the RV slides, jacks, pumps, and lights, or it could be used to start the diesel engine. This 5112 system was installed in our Canyon Star diesel toy hauler, a coach where living off the grid is commonplace for either recreation or business uses. The scope of my 5112 design was to further improve performance and dependability of lithium battery systems for motorhome use. Present motorhomes employ the use of 2 separate battery systems comprised of a house battery group, power the coach, and a chassis battery group for starting the diesel engine and operate dash accessories. How my 5112 system differs from other lithium installations is it incorporates the use of a third battery system called the Inversion Battery Group. The system's sole purpose is for inversion to generate 120 volts to power RV appliances such as air conditioners and refrigerators. The Inversion Group is powered using either 2 or 4 Lithionics high voltage 51 volt modules. As the modules are paired to the Victron Quattro 5000 watt inverter, they produce 50 amp service. This allows the RV owner to power 2 air conditioners at the same time and still have 2,000 watt reserve to power refrigerators or other appliances. The most important feature of the 5112's Inversion Group is it can power these high wattage devices without the heat, voltage sag, and lost capacity, which are common to conventional 12 volt inverter systems. Also part of the 5112's design was to improve the 12 volt house batteries as well. This was accomplished using 12 volt Lithionic modules. What makes the 5112 design unique is the 12 volt system is no longer required to share its power with an inverter. This allows the battery group to be used solely for the RV's 12 volt devices. By increasing the 12 volt system's capacity, we avoid common anxiety of depleted house batteries and extend RV storage time from the constant 24/7 draw of processors. Finally, thanks to lithium's higher voltage and amperage over AGM batteries, there's an improved operation of speed of 12 volt devices such as levelers and large slides. We also eliminate the need of starting the generator or plugging in the RV when operating slides as well. Finally, there's also a marked improvement when boosting or starting the RV's diesel engine with the 12 volt system. One of the most common questions I'm asked from RV owners is why would I want to use a 48 to 51 volt system rather than a 12 volt system? The answer is simple. When compared to a 12 volt inverter system, a 48 volt system operates at 75% less amperage to power the same loads. This lower amperage reduces system heat, losses, and voltage sag, providing additional capacity. While most 12 volt inverter systems work fine for running 1 air conditioner, any additional loads can exceed the 12 volt design heat limitations. As high amperage flows through the system, it heats all the inline components such as wiring, fuses, terminals, and even the inverter itself, causing the fans to run faster and use even more current. This heating can exceed the component's heat limitations, then fail. As an example, during summer use, this owner's Blue Sea fuse holder, which was torqued to specs, failed running only 1 air conditioner, operating well below the rated fuse level. In retrospect, this same AC wattage with a 48 volt system would only require 50 amps instead of 200 amps, and the fuse holder and wiring would remain cool to touch. Keep in mind it takes considerable battery power to heat large cables, fuses, and terminals, which all reduce battery capacity. Other advantages of a 48 to 51 volt system is its ability to use less expensive smaller gauge wire. It also allows placing the battery at a greater distance from the inverter. In order to better understand how a 48 volt system compares to a 12 volt system, let's look at a short clip.
The best way to explain the advantages using a 48-volt battery with an inverter is best illustrated in this example, which uses a 12-volt, 24-volt and a 48-volt battery. For this example, we have the roof air conditioner drawing 1,500 watts, and a 1-burner cooktop using 900 watts for a total of 2,400 watts. As we look at our illustration using 3 different batteries, the 12-volt battery requires 200 amps through its cables and connectors to the inverter to satisfy the 2,400 watt load. However, the 24-volt battery only requires 100 amps to power the same 2,400 watt load, or half the amperage requirements of the 12-volt system. Finally, as we look at the 48-volt system, this battery only has to provide a mere 50 amps to satisfy the same 2,400 watt load, or only 25% the amperage of the 12-volt battery. As this comparison shows, a 12-volt system requires 4 times the amperage to supply the same load when compared to a 48-volt system. When there is heat and losses, there's a voltage drop as well. This is why when we measure the voltage at the battery, it's always higher than the voltage at the inverter. For this reason, a 48-volt system will result in less voltage drop when compared to a 12-volt system. In conclusion, since a 48 to 51-volt system generates less heat and losses with less voltage sag, the result is increased battery capacity.
Getting back to our 5112 system, my first dual battery, dual inverter lithium system was designed nearly 2 years ago. It was installed in this great looking Renegade Verona and this Newmar New Air. This system was powered by 4 630 amp 12 volt Lithionic batteries, outputting 32,000 watt hours of power. Like the Canyon Star, the Renegade system works on the same principles as the 5112 design, except it employs the use of 2 separate 12 volt systems. There's a high capacity 12 volt system used exclusively for 120 volt inversion, and a second 12 volt lithium system used to power the RV's 12 volt devices. This dual inverter system was so well received by the industry and Lithionics battery that the president of Lithionics asked if we could drive the coach to Elkhart and provide personal tours for key personnel for nearly every RV manufacturer, to include Renegade, Jayco, American Coach, Midwest, Forest River, the Red Group, and others. If you're interested in 12 volt single or dual inverter systems, or even a light system for smaller Class B vans, such as the one installed in this leisure RV, I invite you to visit my personal, non-sponsored website at www.rvvolt.com. First order of the 5112 lithium conversion is documenting the coach's present 12 and 120 volt wiring and existing components, designing a layout for the new lithium system, drawing a revised 12, 51 volt, and 120 volt wiring plan, and finally, all new component placement and rewiring should be as non-intrusive as possible to the RV's existing wiring system. Please note that lithium upgrades to the RV's wiring is complicated and can be very dangerous. Therefore, if you're not qualified, seek professional help. Regretfully, RV companies such as Newmar will not provide any 12 or 120 volt wiring diagrams. Therefore, all factory wiring will need to be traced and documented to prepare the new lithium wiring diagram. Part of the 5112's design is having the ability to control the environment of the lithium batteries and support equipment for both summer and winter use. For this reason, the RV's house batteries were relocated from their open-air compartment behind the front tire, where they're exposed to harsh temperatures, dirt, water, and even salt spray in the winter, to a closed compartments on the passenger side where the environment could be controlled. Since the compartment floors are generally bowed, I manufactured non-metallic battery supports which span the battery's weight equally to the compartment's walls. Side bracing was also used to prevent unwanted battery movement and further secured with a winch strap. To minimize use of the Lithionics internal battery heaters, I deliberately positioned the batteries adjacent to the inverter so the batteries could benefit from free heat generated from the inverter itself during winter. This position also allows the batteries to be cabled just inches from the inverter for near zero losses. For summer use, all 6 compartments now share the same airspace for ample summer cooling. Wiring a coach for a lithium system requires extensive pre-planning and countless hours to properly wire. All components must be carefully positioned for easy access or removal. Unlike typical lithium upgrades with multiple exposed wires and dozens of open battery connections, the Lithionics batteries have only 2 power wires per module equipped with bulletproof connectors. The result is when you open the compartment door, you not only have a system you're proud of, but one that appears to be factory installed. I also designed an internal heater system for the Canyon Star, which heats the water lines, pumps, and tanks, avoiding the need to winterize the coach. All the heaters are 120 volt powered directly from the 5112 inverter system receptacles, so in the event of a grid power failure, the 5112 can self-heat the coach. Heating was accomplished using extreme boat and RV heaters available in 300, 450, and 600 watt units, and are manufactured of 6061 T6 aluminum and fully automatic. Each unit turns on at 40 degrees, then cuts back off at 48 to 50 degrees. One of the key features of the Lithionics batteries is they are self-heating and powered by the battery itself or an external 12-volt source. Since the lithium batteries generate more capacity when heated to 60 to 70 degrees, the power used to heat the battery results in no loss of capacity, since this same heat increases the battery's capacity. Let's look at a short clip to better understand how the Lithionics battery heating system works.
Aside from a number of other advanced features of our Lithionics battery, our pack is also equipped with a built-in heater for cold weather use. Unlike import lithium batteries, which are designed primarily for only summer use, the Lithionics battery is designed to be used year-round. While most battery vendors offer an external 12-volt blanket heater for their lithium batteries, since these blankets are exposed to cold temperatures on the outside of the battery, they can consume 50% more power than an internal heater. This is important, since the battery itself is powering the heater when you are off the grid. Another disadvantage with external heaters is they fail to heat the lithium cells equally. This causes an offset in equal cell balancing voltages, resulting in lost capacity. In retrospect, the Lithionics battery heater is installed during construction using a proprietary silicone convection element design. These heater elements are stacked between the cells and therefore an integral part of the battery system itself. As this graph at -4 degrees shows, the internal heater keeps the battery at an efficient temperature of around 55 to 60 degrees. This is important since this same battery at 30 to 40 degrees will have overall less power. Therefore, a heated battery provides more capacity, plus the ability to charge at low temperatures. At -4 degrees on a 50% cycle, the Lithionics heater only consumes 15 to 30 watts an hour to maintain all the lithium cells' temperatures equally between 55 to 60 degrees. Another plus is the Lithionics heater may be shut down completely, or even be powered from a separate 12-volt or 120-volt source for storage. The Lithionics heater is fully automatic, so there is no monitoring needed from the RV owner.
Before I begin our overview of the 5112 system, I'd like to first say a few words about Lithionics. For years, my installations have been powered by Lithionics battery and BMS equipment. Founded back in 2009, Lithionics has become the Rolls-Royce of lithium batteries for the industry. I like to think of a lithium upgrade as an investment for my RV. Aside from the many benefits of a lithium-powered coach, down the road when it's time to trade, a Lithionics system puts my coach at the top of the list. It makes no sense to spend $250,000 to $1 million in an RV, then buy the cheapest batteries you can find, which were assembled in China and sold with no product liability here in the US. In contrast, every Lithionics battery and BMS is fully assembled and tested to meet UL requirements at the Lithionics facility in Clearwater, Florida. Lithionics is the only company in the world to carry a UL 1973 certification on both their battery and BMS. This provides the owner the safest lithium equipment available, and backed by a $5 million product liability policy from UL Laboratories. Before any battery and BMS ends up in our RV, every cell in the battery goes through numerous tests and cycling while undergoing infrared imaging to confirm proper heat dissipation. For additional owner safety, the prismatic cells are mounted in a 6061 T6 aluminum case, so in the unlikely event of a failure, smoke and fire is contained within the metal case itself. This is important since unlike electric cars where lithium batteries are protected by a metal cage, our RV's lithium batteries have no real protection from side impact or collision. As a testimonial, these images were taken at the UL testing facility where this battery was required to withstand a 20,000-pound crush test. Thanks to proprietary mounting of the cells in its metal case, there was no cell failures, smoke or fire, and this pack remained operational. The Lithionics Never Die BMS is also UL tested and certified. Its AMP-seal connector offers RVC CAN bus, serial port, and Ethernet TCP and IP used to control devices such as chargers and generators. Import batteries use an internal BMS and low-cost solid-state FETs for switching. These FETs can easily arc and fail when starting AC units. In retrospect, the Never Die BMS uses military-grade silver oxide contacts sealed in a gas chamber for unparalleled dependability. In order for the BMS to meet UL 1973 standards, these contacts were required to open and close under full load for 6,000 consecutive cycles without a failure. The reason the BMS is called Never Die is because it has the ability to automatically power itself down at a 10% state of charge or any level you choose to avoid depleting the battery to harmful critical low levels. As an example, let's say you left your AC running while you're in a Cracker Barrel. If the Lithionics battery were to reach 10% or any level you set, Never Die would automatically power the battery down. When you return, a push of the button restarts the system again and you have full power in your RV and plenty of time to recharge. This same scenario using an import pack, the battery would not shut down until it reached a harmful critical low level. Making matters worse, the RV is now without power until you recharge. The Never Die BMS also offers the most advanced Bluetooth app in the world, allowing the owner to monitor every detail, right down to how many hours, minutes, and seconds it takes to fully charge or discharge. Let's look at a clip to better understand the Never Die Bluetooth app.
The Lithionics Battery Monitor app is available for both Apple iOS and Google Android platforms. The Lithionics Bluetooth interface does not require pairing. After scanning, your battery will appear as you open the app. Your device's screen will show the battery by name and its unique Bluetooth address. The name typically contains the serial number of the battery, so you can identify specific battery in your multi-battery bank. Signal strength bars indicate connection quality, which typically depends on distance from the battery location and any metal obstructions. Touch the battery name to connect to your battery. If your battery does not appear in the device list, make sure the battery or battery control module is turned on by pressing the power button. Once connected, the app shows the battery status screen where you can see active information about your battery, such as state of charge, voltage, current, temperature, and status code. Note there is a small blinking green dot in the battery state column. This is the heartbeat signal indicating data is being transmitted from the battery. Also note the values are colored either green or red. When values are green, it means the battery is being charged. When colored red, the battery is discharging. Also note, the plus sign appears when charging. The time remaining column indicates approximate duration until the battery is either depleted or fully charged at the current power level. This value will fluctuate as power demands change in the RV. The system's voltage, temperature, and state of charge values are also color-coded and indicate operating range of the battery. When these values turn red, it generally indicates the battery is outside of its optimal state, for example too hot or cold, or in the low voltage state and needs charging. The state of charge bar also turns orange, then red as the battery depletes, to serve as a reminder to charge the battery. By swiping the screen left, it opens the battery details display. Depending on battery model, this lists up to 30 technical parameters. When any battery parameter becomes critical, the internal management system will protect the battery by disabling charging and discharging. The red status code display can be decoded by just touching the value. By touching the gear icon in the upper right corner, you can access the settings screen. Here you can select preferred temperature display, firmware updates, or access the battery's current data, or view previously saved data logs.
Let's talk briefly about down converters and the reason the 5112 system uses a 12-volt lithium battery rather than a down converter to power 12-volt devices. While a down converter may be used on smaller vans and Class B RVs to power lights and a water pump, when it comes to larger Class A's, Super C's, and bus conversions, they lack the amperage needed to power hydraulic levelers and large wall slides, which can surge to over 100 amps as they lift the entire room to retract it. Another very important reason for not deleting our 12-volt house batteries is the down converter has no ability to boost start a diesel engine should the chassis battery be depleted. Until such time our automotive and marine industry moves to 24 or 48 volts, we're forced to work within the confines of 12-volt devices. 12-volt systems in RVs were never designed for continuous, high-wattage devices such as air conditioners, since their high amperage heats the inline components, creating losses, voltage sag, and reduced capacity. The 5112 dual voltage, dual inverter design addresses these problems by incorporating the use of a third high voltage 51 volt battery used only for inversion to provide off-the-grid 50 amp service and avoid past heat related problems of 12 volt systems. Aside from a 51 volt system using 75% less amperage than a 12 volt system, there are inverter benefits as well. Unlike a 12 volt inverter that has to increase voltage 10 times from 12 volts to 120 volts, a 51 volt inverter only has to increase voltage a little over 1 time to produce 120 volts. This means less work for the inverter and less fan usage to keep the unit cool. Another perk is since our Lithionics batteries have a resting voltage of 51.2 volts, they offer a slight advantage over a 48 volt system. Finally, the second phase of the 5112 system is upgrading the 12 volt system to lithium. Aside from the benefits of added capacity, there's also higher voltage and amperage to run devices. In addition, a 12 volt battery is no longer a burden to power the inverter. To better understand the 5112 dual voltage, dual inverter system in our Canyon Star, let's briefly go over these two systems. The 5112 system employs the use of 4 51 volt Lithionic modules mounted on both sides of the coach in sealed conditioned compartments. Together, they produce 30,000 watts of power. If we were to convert this to 12 volts, there's 2,520 amps of power. This is equivalent to 25 100 amp lithium import batteries or 50 AGM 100 amp batteries. A great feature of Lithionics batteries is they're designed for expansion. For this reason, an owner can initially build a system using 1 or 2 batteries, then in the future expand to 3 or 4 batteries by just plugging additional modules into the Lithionics expansion module. This allows the BMS to control each battery. 120 volt inversion is achieved using a Victron Quattro 5000 watt inverter charger and other Victron support gear. The Quattro provides enough power to run 2 AC units, a cooktop burner, and a refrigerator all at the same time. The Quattro, with its great Victron blue appearance, offers all aluminum construction. Its unique design allows for easy access of the processor boards and hookup points. The Quattro features large bulletproof connectors that are easy to reach and secure, as well as a unique and very quiet cooling fan system. The Quattro's front panel design is clean and simple, which offers a number of LEDs to show system status. There's only one mode switch provided, while the front panel only offers basic operations. Once the Quattro is interfaced to Victron's Turbo GX module, the owner can then access and control hundreds of parameters to tailor the system to their needs. User control is accomplished using Victron's GX touchscreen display, allowing the owner to communicate and control every Victron device in the system. The powerful dual-core Turbo GX module is loaded with tons of ports which communicate with every Victron device in the system. The GX even offers smart switches for controlling chargers, generators, or monitor sensors to check fluid levels. The GX Touch graphical display shows the system components complete with current flow between devices and voltages and amperages. The GX also compiles system history, allowing you to look back. In addition to local control, the owner can access the Quattro and other Victron equipment from anywhere in the world using Victron's free VRM wireless network. Using Wi-Fi, the Serbo GX sends out a packet of data every 60 seconds to the Victron VRM network to update the server and your system status. As the owner logs in, they're provided with a graphical view of the system. In addition, the owner can set system alarms, receive emails should a fault or power outage occur. Getting back to the Quattro, one of the best features is Smart Assist. As an example, even if your RV is plugged into 15 amp service, the owner is still free to operate both air conditioners and appliances just as if he were plugged into a 50 amp shore power line. The way it works is as soon as the RV demands exceed 15 amps, the Quattro inverter automatically enters assist mode to provide the needed amperage from the 51 volt batteries. Once these demands diminish to less than 15 amps again, the Quattro automatically stops assisting and enters charge mode to replace the energy it borrowed from the 51 volt battery. Our 5112 solar system includes the use of a Victron 15045 MPPT solar controller. Like the Quattro, the Serbo GX also provides monitoring of the panel's performance via the Bluetooth app, or it can be monitored on the VRM network as well. Our system also includes a Victron DC to DC converter, which converts 51 volts to 12 volts at 30 amps. Since the Orion lacks the needed amperage to run devices such as wall slides and leveling jacks, our converter is used solely to share the 51 volt solar power with the 12 volt lithium system. Our 51 volt battery system is also equipped with a Lithionics ion gauge. This SOC meter provides monitoring and programming of the Lithionics battery and BMS. Menu driven, it can also access dozens of battery parameters or set triggers to control charger or the generator. The ion gauge is also used for setting the never die battery reserve levels. I prefer 20% as a cutoff rather than the default 10% for additional reserve. Finally, the 51 volt service compartment is equipped with 51 volt and 12 volt master cutoff switches and fuse panels. For internet access, I'm using a Wi-Fi Ranger locked to my Verizon 4G Jetpack module. Since the Jetpack is dedicated to the Canyon Star 24/7, the Victron Germo ZX uses it as a connection to the VRM network. The Jetpack also provides Wi-Fi internet for my Apple TV, computers, as well as the coach security cameras and Ring alarm system. Moving to the 5112's 12 volt system, you'll find a single Lithionics 12 volt lithium battery rated at 4,032 watts. This one module replaces the Canyon Star's 6 flooded batteries. Unlike typical 12 volt lithium installations where the 12 volt battery is required to share its capacity with the inverter, this 12 volt system is used solely to power the RV's 12 volt devices. Aside from extra capacity, the lithium upgrade also provides higher voltage and amperage to power the coach's jacks, pumps, and more importantly, to power the large full wall slides, all without the need of starting the RV's generator or having to plug in the RV. For both recharging and secondary inversion, the 12 volt lithium system uses dependable Freedom Pro 3000 watt inverter charger. The Pro offers a built-in lithium protocol and 150 amps to charge the battery in just a few hours. Our Pro inverter is also equipped with a Bluetooth control panel, which allows full operation of the inverter and charger via the Bluetooth app. I also designed the 5112's 12 volt system for redundancy and emergency power as well. Therefore, it's equipped with a secondary 30 amp shore power cord to power the Pro 3000 watt inverter from a second shore power source. Therefore, during visits to an RV park, you're free to quick charge both the 12 and 51 volt batteries at the same time using the Pro's second power cord. In addition, by using an adapter, the Canyon Star's 50 amp power cord can be plugged into the Pro's 110 receptacle to power the coach. The 12 and 120 volt system can also provide temporary power to a neighboring camper, used for outages or even charging an electric car like we do our BMW i3. The 12 volt system is also equipped with a Victron Smart 30 amp DC to DC charger with a lithium protocol. The charger's Bluetooth app allows the owner to set trigger voltage levels to control charging. The charger is powered by the chassis battery and alternator pair when the engine's running. For 12-volt chassis battery maintenance, I added a small 3-amp trickle charger powered by the 51-volt system to maintain the chassis battery's level when parked. While it's not within the scope of this film to show wiring details, the Canyon Star's 12 and 120-volt wiring required considerable modification to allow these two systems to be integrated. The primary reason for my lithium system is I use my coach for business reasons as well. Since the early 80s, my career has been designing and building heavy-lift military drones for frontline defense. For this reason, it's not uncommon for us to be on location at a test site or a laser field for up to a week at a time. Having a high-capacity lithium system is mandatory since there's no AC power available and generators are not permitted. Please note that both 51 volts and 120 volts is dangerous and capable of electrocution. Therefore, unless you have professional knowledge in residential and automotive wiring, I highly recommend that you seek professional help. Let's talk second alternators and diesel generators for a minute. Lately, there seems to be a lot of misinformation that we get free charging when using a second alternator or RV engine, and we no longer need a generator for a lithium system. Regretfully, both of these statements are 100% false. There's no such thing as free engine charging, and an own-end generator is one of the most important components of a working lithium system. I've never been an advocate of using the RV's main diesel engine for high idle or stationary charging for lithium batteries. This practice adds unneeded hours, accumulates carbon deposits on the piston and valves, and is harmful to the emissions and the diesel particulate filter. Since we all paid big money for our RV's own-end generators, it makes sense to use the own-end instead of using a massive diesel engine for the simple task of charging. An own-end generator will burn far less fuel, producing 6,000 watts of power for charging, than a large 6 to 15 liter Cummins engine, producing the same 6,000 watts using an alternator. A 10 to 15 liter diesel engine at idle, without powering an alternator, will burn 0.7 to 1.2 gallons an hour. As we add the load of the alternator, this consumption increases. If an alternator takes 10 horsepower to turn, the fuel needed would be exactly the same if it was attached to a 10-liter engine or a 1-liter engine. We also have to consider drag factor. Since small engines produce less drag, they burn less fuel. Fact is, a 9 to 15-liter Cummins engine will have 20 to 30 times more loss from drag than a 1-liter own-end engine. The main engine's large pistons, crankshaft, camshaft, fan, air, and steering pumps all produce massive drag, which consumes horsepower. Even worse, at idle, the main engine still has to turn the transmission's torque converter and pumps as well. This is why our ICU engine load display shows 12 to 22% power usage when we're just sitting at idle and neutral. For these reasons, I discourage using second alternators which alter the stock belt system when we can simply fire up the generator we already have and instantly have 50 amps to charge lithium batteries. In addition, an own-end is considerably quieter than a Cummins engine. Alternators are air-cooled, so they require a flow of air to pass over the body and fan assembly to release their massive heat. Stationary charging deprives the alternator of this needed cool airflow, which is the reason 60 to 90% of them will prematurely fail. Even when driving down a road, a pusher RV is the worst environment for high-output alternators. Unlike a front-engine RV, which benefits from cool air being forced through the grill and over the engine and alternator to dissipate heat, a pusher's engine and alternator receives no cool air. Pushers using a rear radiator only circulate hot air. Even worse, side-mounted radiators on pushers produce no flow over the alternator for cooling. Keep in mind, I'm not finding faults with second alternators. There's many applications for automotive and marine use where they work fine. However, a pusher's RV environment is far different than other applications. Presently, there are safe 12-volt charging options using your stock alternator. Devices such as ChargeMate Pro or Victron smart chargers provide safe charging options using 30, 50, and 90 amps. In conclusion, by using your solar panel set as a primary charging source and your own-end generator as a backup when needed, you have the best overall combination of off-the-grid charging for 12 and 51-volt lithium systems. Now that we better understand the importance of how an Onan generator can work in unison with the solar panels, let's take a look at the Canyon Star solar system and how it's interfaced with the 5112's dual battery groups. The first step of any solar installation is careful planning of the layout of the solar panels. Avoid packing the roof with panels, since you'll need ample space to service the AC units, dish, and antennas. For our Canyon Star solar panels, I chose Merlin Solar, a U.S. and global company based in San Jose, California. Merlin's been on the forefront of solar panel development and technology since 2012. Their patent-designed panels offer unique grid design using redundant spring interconnects and a proprietary attaching point method. Most important, they offer 20% higher output than similar-sized panels. For ease of installation and cleaning, we chose Merlin's peel and stick flush aerodynamic panels designed to withstand winds of 150 miles per hour. Since flex panels are 80% lighter than glass panels, they minimize roof weight and roll factor for improved handling, especially on tall Class A gas models and B vans. To better understand how our panels are arranged on our Canyon Star, let's look at a short video.
We designed our solar system using 10 Merlin 120-watt solar panels to generate 1200 watts to charge our 51-volt Lithionics lithium batteries. To avoid shading, we separated 5 panels using a series string to the rear, and another 5-panel string in series to the front. The 2 sets were then paralleled to a 48-volt MPPT Victron controller. Since our Canyon Star's 12-volt lithium battery only has to power the RV's lights, pumps and slides, the 51-volt system powers a 48 to 12-volt down converter to charge the 12-volt battery at 30 amps. For this reason, only a single 180-watt panel was needed using a separate Victron MPPT controller for the 12-volt system. As we look at a string of 5 panels in series, we find that each 120-watt panel outputs 20 volts at 6 amps. As we wire our 5 panels in series, the 5 voltages are added together for a total of 100 volts. However, since the panels are in series, the amperage will only equal the value of one panel, or just 6 amps. As we add our second string of panels in series to our Canyon Star's solar array, like the first set, this string will output 100 volts at 6 amps as well. Using a Y connector, we'll now join the outputs of both series strings in parallel to the Victron controller. Since these 2 sets are now in parallel, our voltage will remain the same at 100 volts. However, since this pair is now in parallel, our amperage will be added together for a total of 12 amps at 100 volts to our controller. The Victron MPPT controller will convert our panel's volts and amps into a usable level to charge the Canyon Star's 51-volt lithium batteries at 58.4 volts. During perfect sun exposure, the panels and controller will be capable of producing close to 1200 watts to charge our lithium batteries. When we group strings of solar panels together in series or parallel, there are 2 important guidelines. When solar panels are wired in series, we add the voltage together and the amps remain the same. However, when solar panels are wired in parallel, amps are added but our voltage will remain the same. Finally, while each installation will be different, the gauge of the wire going to the roof, the controller and battery, will determine how we use series and parallel groups to design our system.
There are 2 main advantages when using a large capacity lithium system such as we're using in the Canyon Star. First, it offers the RV owner the luxury of increased off-the-grid time. However, equally important, it allows the owner to capture days or even weeks of free sunlight energy from the panels and stored for use at a later time. While most think solar energy is just stored in the lithium batteries, there's also an immediate power benefit protocol as well. This is where our solar panels can power RV devices in real time right from the controller using little to no energy from the lithium battery. Let's look at a short clip to better understand how this works.
In this example, our roof air conditioning is drawing 105 amps from our lithium battery as the solar panels are producing power. Even though our 8-panel system is capable of around 880 watts to charge our battery at 60 amps, in this example, an evening sun is generating only 500 watts and developing 37 amps to the battery's terminals. However, when we look at our lithium battery display, instead of the battery providing 105 amps to power the AC, it's now only providing 77 amps to run the unit. The reason for this reduced load on our battery is because our solar panels are providing 37 amps to the battery terminals. Therefore, instead of the battery supplying a full 105 amps to run the AC, our battery load is now reduced to only 77 amps, conserving the battery's energy and allowing for a longer runtime.
It's important to note a well-designed off-the-grid lithium system requires three main components. You'll need a dependable and safe lithium battery system with ample capacity, an adequate solar panel system for charging and to assist loads during daylight hours, and finally a dependable on-end generator to power the RV and provide secondary charging when needed. Don't be misled that generators are no longer needed with a lithium battery system. As an off-the-grid RV owner, you'll find it's not uncommon to find batteries in a low state of charge condition. Only an on-end generator can provide standby power and charging to allow you to continue your journey uninterrupted. The scope of the 5112 system, using a third high-voltage battery group for inversion, was designed for RV and vessel owners who demand high amperage and high-capacity systems without heat and losses associated with heavy-load 12-volt inverter systems. To be clear, I'm not in any way implying that 12-volt inverter systems do not work or are not feasible. I've used them in RVs for nearly a decade now, powering AC units with great success. As long as we respect their design load limitations, they work fine. I hope you enjoyed my film on the 5112 system. I invite you to visit my non-sponsored website at www.rvvolt.com for other inversion systems, as well as many other topics. Finally, I'm pleased to announce I'm presently in design and testing phase of my next generation of advanced RV inversion systems, which I'll share with you in the RV industry in my next film. Until then, stay safe.
This concludes our film on upgrading an RV to lithium power. While lithium comes at an expense, when you consider its many advantages for recreational vehicles and its longevity, its investment far outweighs its initial cost. If you would like to see other articles or films from Mike Mass, I invite you to visit his personal RV website at rvvolt.com. Thanks for watching.